Soap, the chemistry of clean. Soaps are so ubiquitous today that we use them without a second thought. You wash your hands, dishes, your car, your dog, and yourself. While washing your hands, have you ever wondered, what is soap? Soap is the salt of a fatty acid obtained by treating vegetable or animal fats with a strong alkaline solution. Before we take a look at the details, let's take a look at soap history.
Evidence suggests the Babylonians were making soap in 2800 BC. An Egyptian soap recipe calls for water, animal fat, and wood ash to be boiled together. So, you boil wood ash with fat and water to get soap? How does that work? By boiling wood ash in water and filtering, people obtained something called lye water.
Lye water is rich in potassium carbonate, which forms hydroxide in water. This is the strong alkaline solution I mentioned earlier. When combined with fats and heated, we get the saponification reaction.
This is a fat molecule called a triglyceride. It's three fatty acids connected to a glycerol molecule by an ester linkage. An ester is a carbon double bonded to an oxygen, called a carbonyl, which is bonded to another oxygen bonded to something else. It's big and messy. To save time, chemists like to use the line structure shorthand to hide the carbons and hydrogens, as well as the R designation to hide things we're not concerned about at the moment. Hydroxide from the lye attacks the carbonyl carbon, which pushes a pair of electrons from the double bond up to the oxygen. The electrons collapse back down and kick out the glycerol oxygen, forming an alkoxide ion on the left and a proper fatty acid on the right. The alkoxide then attacks the acidic proton of the fatty acid to make an alcohol and a carboxylate ion. Finally, a potassium ion in the lye solution is attracted to the carboxylate ion to give us our soap salt.
Have you ever wondered, while washing your hands, how do these little bubbles wash off the grime?
Let's pretend this angry little guy is any kind of germ, dirt, or grime. When we wash with soap, the fatty tails collect around each other and trap the grime inside of a ball called a micelle. This is because of something called the hydrophobic effect, which orients the tails together and the charged heads outward to interact with water. Now that the micelle is formed, the grime can easily be washed away.
Today, there are tons of different soaps out there. When it comes to bar soap versus liquid soap, the differences are minor. Liquid soap is usually made from potassium hydroxide, while bar soap is made from sodium hydroxide because the potassium soap salts are more soluble. Adding a sodium chloride salt solution causes the soap to harden since the salt deprives the soap from enough water to keep it soluble. Industrial soaps are more than just soap. There are chemicals that are added to increase the solubility of the soap in hard water. Hard water is just water with ions like calcium and magnesium. The soap can bind to these metal cations, forming insoluble salts, aka soap scum. Sodium lauryl sulfate doesn't form insoluble salts with hard water ions because of its sulfate head. Therefore, no soap scum. EDTA is added to soaps since it binds to metals and prevents the soap from forming insoluble salts.
The positive health impacts of practicing good soap hygiene are clear. It kills harmful germs and slows the spread of disease, as well as smelling good. However, there are some negative considerations as well. In the debate about antibacterial versus plain soaps, the FDA has concluded that antibacterial soaps are no more effective than plain soaps at preventing illness. How can this be? Antibacterial soaps often include the antimicrobial molecule triclosan. In the studies provided by the manufacturers, bacteria must soak in triclosan-containing soap for 9 hours before it is significantly better than plain soap. So, unless you're planning to spend the whole day in the bathroom, you're safe to stick with plain soap. In a sample of bacteria, some bacteria develop random mutations in their DNA that cause them to form a resistance to antimicrobials such as triclosan. When hands are washed with antibacterial soap, it kills both good bacteria and non-resistant bacteria, leaving the resistant bacteria to continue to multiply and form resistant strains. Starting this year, if manufacturers cannot prove that triclosan is safe for human health, the FDA will prohibit them from including it in antibacterial soaps. So next time you wash your hands with soap, you can appreciate the chemistry of clean.